Welcome. This is Odum Maths. Please don't forget to subscribe, like, and share this channel. Okay, today I want us to look at rules of differentiation under calculus. And then under them we are continuing our discussion on differentiation of a product or product rule. So let's look at these two scenarios. The first one is if y is equal to AU. And then the second one is if y is equal to UV. So here we are seeing a as the constant and u as the function of x. So our dy dx becomes a will stand alone. We look at differentiating u, or we can also rewrite this as a du dx. Okay, so dy dx can also be this, or a du dx. Okay, so this means that that's the first differential. Okay, so if it were to be 2, that is the second differential. So we'll go to high derivative and look at all these. Now, let's talk about the second scenario. So here, our y is equal to uv. Okay, and both u and v are functions of x. So in this sense, our dy dx becomes u dv dx plus v du dx. So we take this, look at u dv dx, that is, we take this one and differentiate this one, plus we take this one and differentiate this one. So after the first instance, we kept u and then differentiated v, so u dv dx. So we differentiated v, plus now we kept v and then differentiated u, so that is also here. Okay, now let's take some examples. Okay, so the first example, find dy dx if I, that's the first one, y is equal to 2x cubed, and then y is equal to, into brackets, 3x squared plus 1, and then another bracket, 5x minus 8. Then the third one, y is equal to, into brackets, 2x minus 1, then another bracket, 3x plus 2. Then the last one, y is equal to, into bracket, 2x squared minus 1, and then another bracket, x squared plus 3. Okay, so let's take them one after the other. Now let me look at this, and then we take this. So this is the first instance we did. That is where we have u to be equal to au, and where a is seen as a constant, and u is seen as the function of x. So here our u is the x cubed, and then a is the 2 here. So the first instance, y equals 2x cubed. So I can say that let a be equal to 2 and then u be equal to x cubed. So my du dx becomes 2x. So then you multiply, x cubed. So here will be 3x squared. So that is this time, this is minus 1 from here. Okay. So then I'm going to multiply the 2. Dy dx becomes, my 2 is there, so 2 times 3x squared. So this and this can multiply to be 6x squared. Now let's go to the second and third and fourth in that order. So let u be equal to the one in the first bracket, so that is 3x squared plus 1, and then my v also becomes 5x minus 8. So here my du dx, so that is going to be 6x, this one will go away. Then my dv dx will also be 5, so this will also go away. So the rule says that dy dx is equal to v du dx plus u dv dx. It can be u dv dx plus v du dx. Addition is commutative. So my v is this one, that is, into brackets, 5x minus 8. Du dx is 6x, so 6x. Multiplying this. Then plus my u is this one. So since it's going to multiply this, let me put it in brackets. 3x squared plus 1. Then dv dx is 5. So times 5. So now let me expand. This and this becomes 30x squared. Then negative 8 times 6 is also minus 48x. Then we are here plus this and this becomes 15x squared plus this and this becomes 5. So we can this and this can be added. So that's going to be 45x squared, then minus 48x plus 5 as the final answer. Now let's take the second example. Okay, so the same way, let's my u equal to 2x minus 1, and then my v will also be 3x plus 2. So that's uv. Okay, so with this, my du dx becomes 2. That is, when you differentiate this one, this will go away, and this 1 times 2 is 2. Then 1 minus 1 is 0, so x to the power 0 will go away. So we have 2. Then dv dx will also be 3, because when you differentiate this one, this will go away, constant to be 0, and then this one too, the x with the power 0 will be 1, and 1 times 3 is 3. So now my dy dx, so dy dx, that says that u dv dx plus v du dx. Okay, so my u is 2x minus 1. dv dx, I had 3, so times 3. Plus v is 3x plus 2. So du dx, which is 2, will also multiply this. So that is going to give me, this and this becomes 6x minus 3 plus 6x plus 4. So this and this can be added to 12x, and this will also be my plus 1. That is negative 3 plus 4 is positive 1. So this is the answer. So let's look at the last example. Okay, so now my u is the first one in the bracket, that is 2x squared minus 1. And then my v is x squared plus 3. Okay, so here my du dx is 4x, so 4x, and this one will go away. Then my dv dx is also 2x. Okay, so the rule says that dy dx is equal to u dv dx plus v du dx. Okay, so my u is this one, so that is into brackets 2x squared minus 1. Then dv dx is 2x, so times 2x plus, now v here is also x squared plus 3, so into brackets x squared plus 3. Then multiplied by my du dx is 4x, so 4x. Okay, so let me expand this. Now this is going to be 4x cubed. Then this and this becomes minus 2x. Then plus, this is going to give me 4x cubed. Then this is plus 12x. So let's see. This time this is 4, then x to the power 3. And then this and this is 4x to the power 3. Now, so let me group and then add the like terms. So this is going to give me 8x cubed. Then negative 2 and this becomes plus 10x. That is that. So please don't forget to subscribe, like and share this channel. The name has always been Odum Maths. See you in the next lesson. Bye.